Okay, participants, I welcome you once again for the next session on critical thinking that will be handled by Professor T. Raja, Associate Professor Automobile Department. I welcome him for his lecture. I welcome once again all the participants for the next session. The session will be handled by Professor T. Raja sir. I am handing the session to Raja sir.
Good morning to one and all. I am Raja, the coordinator of automobile engineering. I first of all thanks to our principal sir and our president Arun Kumar sir and our HOD sir, Professor N. Rajan sir. Today we we talk about critical thinking. What are the things take away from today's sessions? Meaning and example of critical thinking, benefits of critical thinking, skills related to overall ability of critical thinking, steps in critical thinking, role of critical thinking in problem solving in our daily life, the element of critical thinking, strategy and developing of critical thinkers. Meaning of critical thinking. Critical thinking is the ability to think clearly and rationally about what to do or what to believe. Critical thinking is the analysis of an issue or situation and the facts, data or evidence related to it. Ideally, critical thinking is to be done objectively, meaning without influence from personal feelings, opinions, or bias, and it's focused solely on factually information. For example, do you remember putting a tooth under your pillow from the tooth fairy? We might have believed this in our childhood days. Stories hear from parents. Why do we believe? Stories hear from parents. Do you still believe the same? No, because we now critically think about the fact of fairy. We question ourselves about its existence, possibility of magic, evidence of fairy, and much more. Even if we find money under the pillow, we will not think about the fairy. Finding the right solution to a problem with logical questioning. It's critical questioning. You think about when someone has something to say, who, what, where, when, why, how. Before we make decision or judgment about the person, situation, fact, logic, questioning is recovered. Critical thinking, otherwise referred to quality of thinking, involves thinking through problematic situation about what to believe or how to act, where they thinkers make a reason judgments. They embody the quality of a computation thinkers. Why critical thinking? The aim of critical thinking is to promote independent thinking, personal autonomy, or reasoned judgment in thought and action, the ability to reason well and the disposition to do so. Benefits of critical thinking. There are 7 significant benefits of critical thinking. Good decision making, life enhancement, generality, skill booster, time saver, systematic approach, and self-regulations. Skill critical thinking. Like your disciplines of a field of study. First, ask questions. Categorize the main lines of thinking. Find and use of evidence. Find links between arguments. Evaluate the arguments. Finally, related to practice. Related to overall ability to critical thinking. Finding analogicals and other kinds of relation between piece of information. Determining the relevance and validity of information that could be used for structure and finding and evaluating the solution or problems. Analog Galaxy is a huge compared to our solar system. It is a small when compared to the universe. Analyse. Emu, Australia. Penguin, what it can. Self-talk to analog. Ask what is relation between the emu and Australia. And emu comes from Australia, and then penguin comes from where? Where does a penguin live? Then survey the choice. Content, content, continent is a place, but not a specific place. Code describes a place. Antarctica is a place, and penguins live here. Feathers and part of penguin, but not a place. Develop deductive and reasoning. Deductive reasoning is generally too specific. Observation and confirmation is evidence-based. Look at an invalid or valid arguments. For an argument to be sound, it must be valid, and the term is true as well. This is a valid argument, but not true. Bottom-up approach, discover process, but it can be misleading. All people who have meat from Ooty wear fleece jacket. Then all people should Ooty wear fleece. Finding an evaluation solution or alternative ways to look at problems. Used to creative problem solving or future problem solving process. This process helps to solve in effective and imaginary way. Good to use with moral psychology and issue. Good to use with real life problems. Key of critical thinking. Recognize assumption, evaluate arguments, draw conclusion. 5 steps to critical thinking, how to approach it. Background knowledge and information about the topic required for thoughtful reflection. Students can think deeply about the topic if they do not know anything about it. Questions to ask. What background information do students need to make a well information judgment? Second, criteria for judgment. Consideration are ground for detecting why alternatives. So most appropriate. Students need help in thinking carefully about the criteria to use when judging various alternatives. Is my estimate accurate? Is my interpretation? Is my conclusion fair to all? Is my proposal feasible? Usual thinking vocabulary. Students require the vocabulary or concept that let them make important distinctions among the different issue and things task. This include inference and direct observation, generalizations and overgeneralizations, premise and conclusion, bias and point of view. Thinking strategies. They are strategies that are useful for guidance, one performance when thinking critical, making decision, making a framework of the issue, steps to problem solving, organize information, graphic organizer, pros and cons, Venn diagrams. Role talking, have students put themselves in order to person's shoes. Habit of mind, being able to apply criteria and use. Strategy is only useful if the students have the habits of mind, are thoughtful persons. These include open-minded, consider evidence, opposing the views, and revise the view should the evidence want it. Fair-minded are students willing to give impartial consideration and alternative points to view and not simply impose their performance. Independent-minded are students willing to stand up for the firmly held beliefs. Encourage our critical attitudes. Our students include to question the clarity and the support of claims and to seek justified beliefs and values. Critical thinking is skepticism, examining assumption, challenging reasoning, uncovering biases. What is an not a critical thinking? Mere criticize everything, thinking a lot are negatives, blind assumption of authority, memorizing, group thinking. What hinder critical thinking? Lack of awareness or practice, of rational logical thinking. Those ignorant of how to think critically. Personally biased. Some people deliberately avoid critical thinking on situation where outcome may put him in an unfavorable situation. Inherited opinion. Most of the people die with the opinion they inherit from the parents and close one. What critical thinking? Intellectual organs. Due to one education level or qualification, refusing to think critically in open situation. Laziness, intellectual laziness, just lazy to think critically. Black and white thinking, those who think in one of the extremes without considering all the intermediate possibilities. Problem solving with critical thinking. For most people, a typical day is filled with critical thinking and problem solving challenges. In fact, critical thinking and problem solving go hand in hand. They both refer to use knowledge, fact, and data to solve problems effectively. But with problem solving, you are specifically identifying, selecting, and defending your solution. Example for using critical thinking to problem solving. Beyond thinking about anger behavior, you will determine how to might best support the boss, friends, parents, and others in opposite side, and helps in bring the relationship back to comfortable spot. Problem solving action checklist. Strategy and actions checklist. Define the problem. Identify the problem. Provide as many supporting details as possible. Providing example. Organize the information logically. Identify available solution. Use logic to identify your most important goals. Identify implications and consequences. Identify fact. Compare and construct possible solution. Select your solution. Use gathered fact and relevant evidence. Support and defend solution considered valid. Defend your solution. How to practice critical thinking? Critical thinking steps. First of all, analyze, reason, evaluate, validate, and conclude. Use formula logic, use scientific knowledge, look for real world examples. How to do critical thinking? Do careful, intentional thinking, analyze and evaluate each piece of arguments, identify fact and opinion, evaluate the opinion, use of reasons or logic to check the validity, check truthfulness and each fact to see it if the sound argument, application, test with real world scenarios to vary. Crab test. The crab test is used to help you evaluate resources. It is most often used to evaluate websites, but the same criteria can be applied to other type of resources as well. Research literacy, think CRAP. CRAP means current, relevance, accuracy, authority, and purpose. Currency is the information current, and relevant is does the information answer your question. Accuracy is the information supported by evidence. Authority, who is author, and what are the qualifications, purpose, are the author's intentions clear. Snapshot. Critical thinking is a logical and reflective thinking focused on decide what to believe or do. Critical thinking involves questioning and evaluation information. Critical and creative thinking both contributes to our ability to solve problems in variety or context. Evaluating information is a complexity but essential process. You can use the CRAP test to help determine if source and information are reliability. What is an argument? An argument is a set of assumptions, premise followed by conclusion. Example, Socrates is a philosopher. All philosophers like thinking. Therefore, Socrates like thinking. Outcome of the argument. Argument means valid, invalid, sound and unsound. Outcome of the arguments. Arguments is valid or invalid. So valid means sound or unsound. These are the things we consider while go for critical thinking. What is valid argument? An argument is said to be valid if the conclusion is logically true. Whenever all the assumptions, premise are true. Example, valid argument. If there is an earthquake, the detector will send a message. No message has been sent, so there was no earthquake. Invalid argument. Whenever Anil is here, Kumar is also here. Anil is not here, so Kumar is not here. What is a sound argument? If an argument is valid and all the assumptions are found provide to be correct, then the argument is to be sound. We must accept only the sound arguments. Valid and sound deductive arguments. Example, if a husband is a president, then she is the first lady. Parag is a president of USA. Michael is a wife of Parag. Therefore, Michael is a first lady. This argument is valid and sound. Valid but not sound deductive arguments. Example, if a moon is made of green cheeses, then astronauts can eat moon rock. The moon is made of green cheeses. Therefore, astronauts can eat moon rocks. This argument is valid but unsounded.
Now I will share one more video link.
அது எப்படிதான் ஒர்க் ஆகும்
can see one YouTube video related to critical thinking.
Give someone a fish and they'll eat that guy.
Participants, if you have any questions, you can unmute yourselves and you can ask. Okay, I thank Professor T. Raja, Associate Professor, Department of Automobile Engineering, for his valuable informations on critical thinking and what are the process involved in the critical thinking, how we have to make our thinking process in a way to identify the problems. Everything he has explained clearly. I thank on behalf of our principal sir and management and Institution Innovation Council of our college. I thank him for his wonderful presentation. Participants, you can join in the afternoon session around 2 o'clock with the same link. Right now, you can leave the meeting and you can join by the next session around 2 o'clock, and it will be handled by Professor Saravanan sir. In the evening session, that link will be shared around 4 o'clock for feedback. You can join using the same link in the afternoon session. Thank you all. You can leave the meeting. I welcome Dr. M. Saravanan, Assistant Professor, Mechanical Engineering, as a resource person. He is going to deliver the lecture on the topic innovation design. I hand over the session to Dr. M. Saravanan. Dr. M. Saravanan, sir, you can continue your session, sir.
Okay, thank you, sir. Good afternoon to one and all. First of all, I would like to thank our principal, Dr. A. Nagappan, and Dr. C. Arunkumar Madhuppan, IIC President and Management, for giving me the opportunity to present a webinar on innovation design. So, in the forenoon session, Professor N. Rajan presented about design thinking, and Professor T. Raja give the presentation about the critical thinking. Now I am going to present about the continuation of design thinking and critical thinking. So I am going to present about what is innovation thinking. So innovation design. So what is innovation design? So first of all, so innovation design is nothing but it is a process of identifying, pinpointing, and understanding the needs of the user or audience. So instead of creating a new product and selling it to the market, so in innovation design, we are identify and pinpoint the problem. We are identify the problem, or we are identify the product and pinpointing and understanding the according to the needs of the user and our audience. We are going to design based on the requirement. It is the customer centric, based on the not designer centric. So according to fulfill the customer need, or to fulfill the audience, so we are going to design. So once the need has been identified, a solution can then be designed. So that is based on the customer need, we are going to create the design. So it is not a designer that is a uses. Designer is not going to design their own product. Everything is designed based on the customer needs. Without customer, there is no need of because every product is designed for to manufacturing. Final stage is manufacturing. That product should reach the market. So there is a customer to buy the product. Without any customer, there is no need of the manufacturing, no need of the design. So everything is nothing will be there. So everything is based on the customer need. So here there are three types of innovation. So one is product innovation, another one is process innovation, third one is business model innovation. So let us see what is product innovation. Product innovation is defined as the development of new products or changes in design of established product, or in the changes in the existing product, or use of new material or components in the manufacture of established product. So if it may be a new product or the modification in the existing product. So the example, which include the introduction of the new product, enhanced quality and improving its overall performance. Next, process innovation. So process innovation is a new or significantly improved way of doing things in a business that typically increases production levels and decreases cost. Process innovation might come in the form of new process or techniques, new equipment or software. So it deals with the processing, not the real product. How to process the product. Next, business model. Third one is business model innovation. It is the conscious change of an existing business model, or the creation of a new business model that better satisfies the needs of the customer than the existing business model. So business model, business environment. So according to the new technology, you have to adapt. According to the customer, factories also we have to change us according to the based on the current trends. Is a business model innovation. Next, what is then when it goes to innovation, then there will be an innovation designer. So what do you mean by innovation designer? So innovation designer is nothing but a practitioner with a diverse toolkit of capabilities that enables them to support teams and organizations through the transition from where they are now to where they need to be tomorrow. So the innovation designer that is who is a design person. So he will apply a different tools to enable the organization and the teams through the transition from the current position to they need what will be the position in the future. So there are the 12 competencies that the innovation designer they have the following 12 competencies. First one is the leadership, innovation leadership. So leadership means inspiring, selling, pitching, reframing. So then strategic foresight and innovation strategy, design research, service design, product development. So these are the characteristics, the knowledge of the innovation designer. This knowledge they have to have. Product development, visual design, writing and storytelling. So they have to written, spoken, audio, visual, everything they have. These capabilities should be possessed by the innovation designer. Then process design and facilitation, organizational and the culture change. Next, team development and coaching, business design, systemic design. These are the 12 competencies of an innovation designer. So now let us move to when it comes to design is not a single step. It is a step-by-step procedure. First, we have to identify the problem, or we have to identify the potential. There is no problem, no need of any design change. Or if it is a new component, we have to identify the potential for new product. So after identifying, then only we have to start the design. So there are several steps. There are several models is there. So school, the Institute of Design at Stanford, they have devised the 5 stages the design process. So other than that, there is some other important model, Sigley model, Pearl and Fates model, Osuga model, Early model. These are the different models. So they will be telling some different ideas. But when it comes to design, there are a lot of steps that should be followed. So it's first we have to identify the problem. That is a recognition of the problem. Then the problem should be defined. Then we have to know what is the competitor in the market, the product. Then what is the price, existing price? What is the facilities? What is the features available in the existing product? So what is the market need? Can we survive? If you design, if you manufacture the product, can you sell the product into the market? So there are the various stages that should be followed. And so first problem identification, then it should be defined. Then we have to go for synthesis. Synthesis means that is a more number of design that should be created. Then the design should be analyzed. Based on the analysis result, again it should be fed back, iterated to the synthesis stage. Then it should be evaluated. Then it should be presented. There are different stages, but the design process. So I think this portion was covered by Professor N. Rajan in the morning. So this is the 5 steps that will be according to the Institute of Design at Stanford. They are telling. I am not going to discuss in depth. So already we have seen the empathy. Empathy means that is the ability to understand the thoughts, feelings, or emotion of someone else. So empathic design is nothing but a user-centric design approach. The ways that pays attention to the user's feelings towards a product. So these are the first step in design process according to the D school. So next the problem. After identifying the problem, so that should be defined. Define the problem. So during this stage, put together the information you have created. First, information should be gathered. What are the problem that should be listed? What are the constraints? Constraint means that cannot be solved. Everything should be listed. That will be told as a design brief. You have to make what will be the problem, what will be the solution, then what material we have to use, what technology we have to adopt. Everything you have to list. What is the constraint? What will be the cost of our product? Everything should be in the second stage. First you have to identify. After that it should be listed. That is a problem should be defined. This is where you will analyze your observations and synthesize them in order to define the core problems that you and your team have identified up to this point. After that, ideate. So already we have discussed in the forenoon session. Ideate is the mode of the design process. So in which you concentrate on idea generation. You have to get more ideas that should be generated. After that, from that idea, it should be refined. There's a different idea. Different person will be telling different idea. But we have to choose the best idea. That is a refinement. Unnecessary things that should be avoided. So so mentally it represents a process of going wide in terms of concepts and the outcomes. So ideation provides both the fuel and also the source material for building prototypes and getting innovative solution into the hands of your users. After that, you have to go to prototype. Prototype is nothing but that is the model of the product before going to the final manufacturing. So it is an early sample model or release of a product built to test a concept or process. It is a term used in variety of contexts, including semantics, design, electronics, and software programming. So a prototype is generally used to evaluate a new design to enhance precision by system analysts and users. So prototype is a simple experimental model of a proposed solution used to test or validate ideas, design assumptions, and other aspects of its conceptualization quickly and cheaply, so that the designers involved can make appropriate refinements or possible changes in direction without investing much in the business. So in the prototype itself, we can check, we can modify the design based on the result. So when it comes to prototype nowadays, everything is going, every design is going by using the CAD, computer aided design, computer aided manufacturing. Everything is based on the computer. So previously it was done by using a clay or some other material. Now, so it is based on the CAD database. So that is the Rabbit prototype. So it is popular now. So Rabbit prototyping is the fast fabrication of a physical part, model, or assembly using 3D computer aided design, CAD. So once you create a design based on the same data, design database can be just, for example, we are typing in the MS Word, then when you give the print, then we are getting the printout in the paper. That is a 2D. But here in Rabbit, it will be a 3D. You are designing a model. When you print, when you give a print, so we are getting the 3D object. So the creation of the part, model, or assembly is usually completed using additive manufacturing, or more commonly known as now the 3D printing. It is popular. It is just now we are taking the printout in the paper, that is a 2D. Here 3D means original model based on the CAD database. It will be done. That is called like additive manufacturing. Additive manufacturing is uses a data of computer aided design software or 3D object scanner. So there is a scanner, you can scan the 3D object. So it will direct the hardware. That is, it is just like the printer, 3D printer will be there. The 3D scanner will scan the object, or real 3D object. It will be sent to the 3D printer. So that is a hardware to deposit material that will be layer upon layer, one by layer. So material will be deposited in precise geometric shapes. You will be getting the geometric shape. So additive manufacturing is nothing but that add material to create an object. So when it comes to Rabbit prototyping, there are different methods of Rabbit prototyping. So mainly there are 7 important methods is there. So that is nowadays is popular. So first one is SLA, stereo lithography, selective laser sintering, fused deposition modeling, selective laser melting, laminated object manufacturing, digital light processing, binder jetting. These are some of the important methods that is nowadays used for Rabbit prototyping. Next one, once the design engineer. So invention design, the invention designer will be there. Not only designing, they have to design. They have to in the 70% of the manufacturing cost will decided by the design stage itself. Remaining 30% of the manufacturing cost that will be decided by the manufacturing stages. That will be the cost of the material like that. So in the design stage itself, they will be decide what will be the product cost, 70%, what material we have to use, what will be the accuracy, what will be the tolerance, what are the manufacturing method we have to adopt, what machines we have to use. Everything will be design stage itself. Then so we have to go for, so first after completing the design, then you have to go for prototype. After that, process plan. After that, you have to, the design engineer also have to think it over about the production process. So preparing the detailed process planning, then tool and pictures, design of tool and pictures, then planning to acquire new production facility because some machines may not be there. Then the design stage itself, they have to plan, or some work may be given as a subcontracting. So this is also the design engineer's duty. Then the quality control. So quality control inspector will be there, but then the design drawing will tell you about the various, the size, what will be the dimension, what will be the accuracy, everything, what method, what inspection method we have to adopt, everything will be decided by the design engineer. That will be sent to the quality control department or quality inspector. They have to act according to the design engineer, design drawing. So that is the planning for quality control system, then the planning for production personnel, then what are the skilled workers, how many what is the manpower required, everything that will be decided in the design stage itself. Planning for production control, then planning for information flow, feedback system. So this is the planning the production process. After that, so the production is over, then it is going to distribution. So it should reach the customer. That is also the, in this stage also the design engineer plays some important role, because without packaging we cannot supply, we cannot distribute any product. That should be properly packaged to avoid the damage, vibration, shock. So everything based on the product. So outer shape of the product, you have to design the packaging of the product. That is also the design engineer's duty. Then planning the warehousing system. Product is ready, that it should be kept in a stored in a proper location. So you have to choose the economic place that should be more rent. So rent should be less. The economically favorable location that should be chosen as a warehouse for warehouse. Then planning for promotional activity. Promotional means then advertisement, pamphlet, everything that should be kept ready. The operating instruction, everything that should be planned by the design engineer. Then planning for additional attachment features. Some basic model, some basic feature will be there. Some based on the customer needs some additional attachment that should be also planned in the existing product. So then after distribution, it is going to consumption. So this is the design for consumption. So it is the duty of the design engineer. Based on, they have to keep the consumer in mind, because consumer is the valuable person. There is no consumer, there is no design, no manufacturing. After manufacturing, there should be a customer to buy the product. Customer satisfaction is very important. So that should be also planned in the design stage itself. That is the plan, design for maintenance, design for reliability, design for safety, design for convenience of use, design for economic operation, design for aesthetic future, design for adequate duration of services, design for environment. These are the important key points that should be kept in mind, because everything is important in the customer point of view. They, for example, they will be expecting the safety. The economic operation means for example, you are buying a car or bike, you will be expecting more mileage. So buying a product is one-time investment, but operating cost should not more. Buying a, for example, we are buying a bridge or air conditioning. So air conditioning, it should consume less power in such a way. That's why now they are giving the star, 2-star, 3-star like that. Power consumption would be less. So because 20,000, 30,000 you are investing to buy the AC. After that you have to pay 3,000, 4,000 as a electric charge. It is the consumer will not prepare. That is the in the design stage itself, the design engineer should be planned. So let us see what is that is maintenance. The maintenance should be less. You are buying a product, it gives much trouble, then the customer will not choose your product. There are so many competitors is there for a particular product, because it is a globalization. So any product, anybody can sell the product in any country, but some competition is more. So maintenance. So design for maintenance is concerned with the achieving good design that considers the general care and maintenance of the equipment and the repair actions that follow a failure. So you have to plan in such a way the maintenance should be less. In such a way you have to plan. Next, design for reliability. That is ensure that the products and systems perform a specified function with a given environment for an expected life cycle. It should be a reliable product. So reliable means trust. Engineers often talk about the reliability. In fact, it has on a product's overall efficiencies and success. After that, safety. When it comes to safety, it should be your product. For example, there is a power block. When you insert a power point, there should not be any electric spark. In such a way, you have to design. When you use a knife, the handle that should be properly proper handle that should be given. Otherwise, so it should be in the insured. So that is a safety, design for safety. It provides design engineers and engineering managers a range of tools and techniques for incorporating safety into the design process for complex systems, because the operator, the end user may be the uneducated person, anything may be. So the product should not be unsafe. It explains how to design for maximum safe condition and a minimum risk of accidents. In such a way, the design engineer has to design. That is a design engineer's duty. Then the design for convenience of use. So product should be designed for customers' convenience. So the technology and innovative design have made many products and services more predictable and efficient. Convenience means, for example, you are buying a cell phone, everybody can use. In such a way, it should be simple. It should be simple. It should not be very difficult to use the mobile phone. Now they have Mac. Every he is an educated person or uneducated. Anybody are using the touch screen. So it should be simple in such a way. The software or the pro circuit, the hardware, everything they are planning. So next, design for economic operation. Economic means the product should be designed in such a way that the operating cost should be less. So, for example, already I told power consumption of washing machine, air conditioner, refrigerator, etc. That should be less. In such a way, the product will be there. So, the power consumption is important. Previously, for example, they designed the filament bulb. That is, it has been stopped because it consumed more power, gives less light, it emit more heat. Then new technology has come. Then new technology has been adapted. That the design engineer going for the new technology and the LED bulb, CFL bulb like that. So that will be the economic operation. It gives it consumes less power, gives no heat emission, also more light, more brightness. So in such a way that is the design engineer should think it over. Next, the design for aesthetic features. Aesthetic is a core design principle that defines a designer's pleasing qualities. In visual terms, aesthetic includes factors such as balance, color, movement, pattern, scale, shape, and visual weight. That is an aesthetic look. Designers use aesthetic to complement their designs, usability, and so enhance functionality with attractive layouts. So aesthetic means that it should be attractive, it should be the smart. So in such a way, they have to design. Next, and it comes to designing the design for. Then again, the continuation aesthetic feature, that is the visual aesthetic. How this key element, visual means color, shape, pattern, line, texture, visual weight, balance, scale, proximity, and movement. So, for example, when you take a bike, the youngster will be choosing the shape of the bike, color. So that will be the functioning will be the same, but they are expecting some the taste. The youngster taste will be somewhere different and compared to the old age person. So that is the aesthetic look. So when it comes into the sound aesthetic means they have the loudness, pitch, beat, repetition, melody, pattern, and noise. So for example, when we are going to buy the headphone, we can buy from it ranges from 200 or 100 rupees to 1000, 2000 like that. So that will be based on that is the sound aesthetic. The quality cost is more when it comes to that it will be a very melody. The loudness will be nice, error that will be less like that. That is the sound aesthetic. Based on that, cost will differ. So this will be everything will be in the design stage itself. That should be planned. Next, design for adequate duration of service. You are buying a product, for example, you are buying a cell phone, it should last long. After 1 year, it gives a trouble. The customer will not prepare that company. It should last long. That is, it gives some trouble in battery or some touch screen. So the customer will not feel better in your product. So design for adequate duration of service. The product should last long and should satisfy the customer need for a long period of. After that, when it comes the environmental issue, that is the design for the environment. The environment is very important because nowadays, for example, when we take a Maruti 800 car that has been given retirement because it emits more pollution. So then, in the engine also they are bringing some new technology in future. So, for example, in England also they have decided to vanish the petrol and diesel vehicles after 2030. In India also the moving towards new battery electric vehicles because that is due to the environmental issue. So the design engineer also based on the environment they have to kept in mind. Environment is very important. So it is a design approach to reduce the overall human health because pollution. It should not be it will be pollution or noise also. Your design gives so much noise. That is also the noise pollution. So a design approach to reduce the overall human health and the environmental impact of product, process or service, where impacts are considered across its life cycle. So the program provides information regarding safer chemical formulation of cleaning and other products. Next, planning for last stage. So the design engineer design, then after that it will be going to process plan, then manufacturing. After that they are planning for some based on the distribution, customer needs. They are planning. After that, the design stage, every product has a retirement. For example, when the satellite is launched, they will be fixing in the design stage itself. What will be the 3 years, 4 years? After that, it will be given retirement. Not only satellite, all the vehicles also, aeroplane, ship, everything has a particular service life. Everything will be decided by the design engineer also. That is a retirement. So that will be there are two type of retirement. One is physical deterioration. Another one is technical obsolescence. Physical deterioration means that will be you are using a material, some damage, depreciation, wear and tear will be there. Physically it will be damaging. So the retirement you have to give. The performance will be reducing. Then after that, it will not be safer to operate old buses, old ship, old aeroplane. That will be after a particular end of time they are giving the retirement because it will be operation will not be. It is a possible for the failure in some in any parts. Next one is technical obsolescence. Technical means when the new technology comes, old technology will disappear. So based on the technology, you have to adapt in the cell phone, TV, electronics industry, in the car also. 50 years back you take or now you take compare new more several technology have come. So old technology should not be adapted because there are so many problem will be that why they are going for new technology in the communication also. 2G, 3G, 4G, 5G, like that it is going one by one. So once the new technology comes, old technology will be vanished. So that is the technical obsolescence. So these all are the that when it comes to designer, that is a innovation design. That is a innovation design is based on the customer, not a design. Design engineer design. It is based on the design. It is manufacturing. It is going to the market. Then after that there will not be no customer because in the market there will be some other good product. So design engineer has to keep the customer in mind based on the customer need, because you have to search the existing product or what are the products. Some other competitors will be there. What are the products? What is the futures? What will be the cost? For example, you are making a product, new product. The cost of the product is much higher than the existing product. So the customer point of view, they are expecting more quality with less cost. So in such a way, the design engineer, innovation designer, they have to keep these points in mind to design the product. So before wind up, I am going to play a 10 minutes YouTube video that will be explained about picture. Will be explained about the what is innovation design. I will share the video. Sir, video is audible.
In this episode, innovation, revolution.
Sir, no, video is not audible. The video is not sharing.
So is it audible?
No, sir. No, sir. Video also not sharing.
Not sharing it.
Yes.
Only picture is visible, sir.
Adding a cushion to a chair is innovation. Innovation. Manufacturers, I watched that a long time now. Innovation function. Maybe just one item. On the item itself, it depends on one item. It has a big impact on your cost. Not just economic, but also. So there are two sides to innovation. And the innovation becomes, I think, the greatest advantage. Because requires already so well established. Just by changing form. As an example, all of the rackets have materials have really advanced, strong. So innovation always about that. Innovation. There are a lot of well, it takes quite a bit to do what process. So, well, that's the training example. But disproportionate. Innovation. Those things are often hard with. Not really fraction. So, some people strong on. That's why this is so common. Not innovative. Especially in areas like consumer electronics. It's the same thing over and over again. It's rare like budget brand gold. All innovation happens where best example of the saying all the price. The makes it so more aesthetic or otherwise. So if we park improving the product by its life cycle, how else can we? Innovation becomes simply through the design philosophy. Why design? A long time ago, I was introduced to the principles of inclusive design. If I design an object for a person with my test the hardware, I improve the design for everyone. A simple example is the design of the closed paper service from hardware. Expert pressure on our fingers. So redesigning the peg made it easier because so hopefully that's for everyone else as well. The materials that I use are exactly the same, but my design philosophy and carefully listening to my target market and what helping me make them. Another method is to observe products from different areas and combine their functionality to a new product breakthrough. I use pastors, correction rollers, and selectively. My designer's intuition tells me that somewhere in the combination of these products from different areas could be an innovative product. But with this method, you're waiting to happen. It's not problem-led, and so it's rare in success. So what I wanted to show you, because this isn't one of those series that just talks about design, and especially as this is the first episode in my series on product design, is how to innovate through getting the right brief. Brief is the start of every successful project, and I cannot stress enough how important it is for you to answer the brief properly, and for companies employing designers to give them the right brief. So it's important that where possible, the designers work with the client to create the brief together based on discussion and design result. There are lots of examples in advice on how to construct a brief on the internet. but I wanted to show you how it's framing the brief directly affects the outcome. So to demonstrate, I'm going to follow two briefs to design a vegetable movement. I've chosen a vegetable movement because it's a simple two-piece design, but with innovation it's worth considering so the less complex the product, the less opportunities there will be to come up with something new. So today, because I've only got two parts, my task is going to be harder. The first brief is to design a home cook's vegetable peeler using a standard blade. I've looked at the hard points, the things I have to use in design. In this case, that's the peeler blade and possibly the handle blade. I've also researched other competitors' peelers and looked at people's behaviours to try and find improvements. As soon as I'm given a brief, my head fills with a myriad of ideas, and I find the first thing to do is get all these preconceived ideas out of my head onto paper, so that my mind can be open to let new ideas in. I spend a lot of time working ideas up in plan because I find it's the fastest way to work a concept that I can then make quick molds from. Using the existing peeler blade, I generated lots of forms. Whilst I looked at areas with different grips and DIing ideas, the only vaguely innovative element I've been able to incorporate is a scraping device. So here's a rough model of my final design that I've made in wood. I've extended the DIing area across the top of the blade holder to create scraping elements for peeling vegetables, and I've removed material from the handle without sacrificing comfort or grip to make the product lighter and more economical and environmental. But as you can see, it's not very innovative at all. Now let's look at framing the brief another way. What if the brief is to design a method for home cooks to remove the skin from vegetables? It's a subtle change to the brief from designing an object to tackling a problem, but instantly this opens up such a huge range of possibilities. Now my investigation can be really broad. I can go to all sorts of areas, files, payments, files, rasps, scrapers, brushes, ways this is done on an industrial scale, diversity. Play with lots of things and ask questions. Vegetable or a solution which removes skin. I can have fun with it, which is why product design can be one of the best jobs in the world. With product design, every time I design, I get to explore, and I feel like I go on an adventure. At this point, all ideas have worked, but admittedly, some are definitely better than others. I mean, solutions to remove the skin from vegetables may sound daft, but my research shows that this has been used commercially to soften the skin of hard vegetables before mechanically scraping them. I still want my design to be used in a hat and be small enough to fit neatly into a cupboard drawer. I also don't want it to use a motor, as I believe on this occasion it's unnecessary, and because I believe product designers have a responsibility to design mass-produced items that use less material without affecting functionality. When I look at my current spool, I notice the leading blade that guides rather than cuts has become worn and dulled from being scraped across vegetables. I'm right-handed, so this peeler wouldn't work well with someone who uses it left-handed, which is one reason everyone has their blade. So my first concept looked at ways to keep the blade sharp by protecting it or having it pivot out of the blade. I then looked at ways to adjust the height of the blade or move the guide up and down to get a thicker or thinner peel. Trying to get a thinner peel, then to investigate saving it by making thinner peelers. Most vegetables are rounded and much smaller than this plate. Peeling a 1 mm deep slice would only need a blade this wide. But the problem with taking a slimmer slice is that you have to peel many more times to get around the vegetable. So I then looked at trying to curve the blade, which is near impossible, or using lots of shorter blades to make a curve. I can learn a lot from a quick paper model. But when this design isn't kept flat to the vegetable, the the back blades lift, so only the front ones keep contact. Not very effective. So then I experimented with designs to get the blades to cut in line. So, skipping a few stages, here's my final design. I'm not going to pretend it's brilliant, but hopefully this is a useful demonstration of simply choosing how to construct a brief can promote innovation. I hope now you see the results from both briefs. You can see that if I just step the first brief, I would only have had a very limited number of concepts that were not just purely aesthetic. Whereas using the second brief, you can see that the range of innovative concepts I was able to generate was much larger. By designing with both briefs, I get a mild to wild range of concepts I can then present to the client. One brief focuses on defining an object, the other is interested in an outcome. One final note, not everything you design will be a success. Apple only takes 2 out of every 10 designs they work on. Sometimes you can't reinvent the wheel. It isn't necessary. There isn't time or budget for it. There isn't a public demand for it. So choose to implement care. Once you have come up with something, you may have applications in other areas. So be prepared to capitalize on the hard work. I need to scratch my head on where else I can do this. So useful. This series takes a while to put together, depending on several factors coming together. So unfortunately, I cannot give you a time when the next will be released. The only way you're going to be alerted to this, if you're interested, is to please hit subscribe. Factors coming together. So unfortunately, I cannot give you a time when the next will be released. The only way.
So okay. Okay, thank you, sir. So any question? Hello?
Sir, wait பண்ணுங்க sir.
Okay.
Participants, if you have any questions, you can unmute yourself and you can.
Hello, sir. Hello. Hello.
Hello? Hello?
Hello. Hello, sir. Hello.
Sir, சொல்லுங்க sir.
Sir, any design thinking tools are available, sir? Systematic way. Bringing the innovation in systematic way.
So nowadays the software, by using the software, some software is there, sir. We can
Okay, sir. Okay, sir.
by using the software we can generate, sir, ideas.
Okay, okay, sir. Thank you.
Right.
Participants, the feedback link has been shared in the chat window. You can use that to generate your certificate.
Hello.
Hello.
My dear participants, I thank on behalf of the institution for attending this one-day workshop. I have to thank the resource person, Professor Rajan from Mechanical Engineering, Professor Raja from Automobile Engineering, and Dr. N. Saravanan from Mechanical Engineering for their wonderful guidance on this entrepreneurship, particularly on design thinking, creative thinking, and innovative thinking. I thank all the participants for their kind cooperation, and I have to thank Dr. Arun Madhavan, President, also for organizing this activity as one of the activity of IIC. I thank one and all. If you have any clarification on this particular subject, you can contact these three resource persons, and their mail ID are available with Dr. Arun. Any clarifications? Or you want to give any feedback? You can give the feedback through Dr. Arun Madhav. Thank you very much. Thank you, Ananda.